Now I will show the sublane behavior that the behavior motorcycle occupy one lane and the in between lane movement of motorcycle in sumo. So for doing that we have to write sumo dash GUI space dash C for configuration, then write the file path and give the space, then there is two dash and write lateral dash resolution and give a space and write zero point 0.6. If we reduce the value less than 1, the more it is less than 1, the more it will have some granular sublane behavior for motorcycles. So for optimality, I use zero point 0.6 here and I write this in the Windows in the command prompt, then run it. My model is open in the SUMO GUI, convert it to real world, and for simplicity change visualization slow blinker or bike light, reducing it, then reduce the delay time. Say our delay time is 50, and now run the simulation, observe how the simulation is moving. We can see the non-lane behavior of motorcycles here. In the east-west bound direction, east-west to eastbound direction, we can see the non-lane behavior of by motorcycle in the simulation. We can watch that even vehicle are using, cars are using non-lane behavior and bikes are mostly in non-lane. Whenever in the signal, three bikes are stopped in two lanes and motorcycles are trying to seeking behind or around the cars to get the space. Is the actual behavior of motorcycle that is observed in real world scenarios. Here we can see there is multiple motorcycles sneaking in, occupying the same lanes. This is modeling of a signalized intersection where we can see that the non-lane behavior by motorcycle, or there is option named as sublane behavior of motorcycle. So we can see some more signalized intersections so that the motorcycles are behaving more like real world scenarios. So that's it about the situation. Actually, the things we have to do, I am stopping the simulation for a while and go to the presentation. Here, the things I am presenting here is that incorporating motorcycles into sumo simulation. So firstly, I create a road network and define motorcycle vehicle type in the NetEdit, then adjust lane change and overtaking behavior of motorcycle, and give the provide the network and lane configuration, then run and observe simulation, which I have already shown, and match motorcycle behavior with real world scenarios. So to adjust the motorcycle behavior, we have to create a motorcycle vehicle type, and it will be within motorcycle, and width will be zero point 0.8 and minimum lateral gap will be 0.2. We have to reduce the minimum lateral gap, and width is already provided in width for zero point 0.8 is already provided in the uh, SUMO. Lateral alignment, usually it is center, but for motorcycle, we have to provide it nice so that laterally motorcycle will give side to other vehicle. Maximum speed is 40. We can reduce it or increase it. Sigma value, that is platooning effect, will be 0.4. We have to reduce it so that vehicle will come as platoon, especially motorcycle may come to platoon. And lane change speed gain, we have to reduce this to 0.5, and lane change opportunity will be reduced to 0.5. This behavior will give motorcycle more real look. And to network configuration, what I have already shown in very first of this video, to simulate the sublane behavior by motorcycle, we have to write sumo dash GUI and this code. The code displaying here, we have to write this code in the command prompt, and resolution, lateral resolution is usually 1 for default case. The much we reduce, the much it acts like sublane behavior, or the motorcycle will behave with more lateral resolution. So I'm using zero point 0.6 here. And that's it about, and let's again go to my simulation run, see my simulation. Then see two motorcycles occupy one lane, and even beyond the intersections, signalized intersection, motorcycle are acting uh, more like non-lane behavior, and they are sneaking from the lanes. They are trying to occupy, maybe two or three vehicle occupy same lane. Sometimes they are moving in between two lanes. That's the behavior of motorcycle we can simulate in the SUMO. That's it. Thank you so much.